Okay, so this is Julie, and I'm going to demonstrate a program that simulates a simple vending machine so that I can demonstrate using logical operators and validating the data fits within a range. So for this vending machine, I'm going to want to have a variable for the user selection, and I'll use an integer for that. And then I'm also going to have a double for the price of the item that the user selects. First thing I'm going to do is display the menu of items that the user can choose from. And so we'll have Oreos, chips, and a couple of drinks. Like I say, it's a very simple vending machine. And how about Sprite? Okay. So now that we've displayed the menu, I'm going to get the selection from the user. I'll use a cn statement, and I'll get that selection and save it, selection, and save it in the variable selection. So now users don't always follow directions and choose one of the valid options. And so it's a good idea to see if they did choose the correct item. So there's a couple of different ways we can do this. We can check to see if it is valid, or we can check to see if it's invalid and outside of the range. I'm going to do this. I'm actually going to show you both ways, even though you'd really only want one in your program. So first, what I'm going to do is I'm going to see if it is valid. So I want to make sure that the variable selection is between the numbers of 1 and 4 inclusive. So I'm going to see if the selection is greater than or equal to 1 and selection is less than or equal to 4. Now it's very tempting to write this like you would in math, where you would say selection, or rather 1 less than or equal to selection less than or equal to 4, or something like that. But we can't do that in C++. We have to compare selection to each of the boundaries separately. And so I'm going to compare selection to 1, and I'm going to compare it to 4. If both of these are true, then we have a valid selection. So that's one way we can do this, is to see if the selection is valid, or we could do the opposite and we can see if the selection is invalid. And we really probably wouldn't have a reason to do both of these, but it's good to see how both of them work. So invalid would mean that the selection is less than 1, or the selection is greater than 4. So when I'm trying to see if a number is outside of a range, I'm going to check to see if it's less than the minimum. I'm going to use the logical OR symbol with the 2 pipe symbols. And then I'm going to also see if it is greater than the maximum. So if either one of these is true, the number is not valid. And in fact, because I don't know how to use a loop yet, if they don't choose a valid selection, there's really nothing else I can do in this program. So I'm going to put a return. And the program, in a sense, didn't really run correctly because we didn't have a valid selection. So I'm not going to return 0 this time. I'm going to return a 5. So if something was calling this program, then it would know that this program did not successfully make a vending machine purchase because it would see the return value of 5. So we checked if it was valid by making sure that it was greater than or equal to 1 and less than or equal to 4. Or we can check if it's invalid by checking if it's less than 1 or greater than 4. Either one works. At this point in the program, I can assume that I have a valid number and I don't need to test for it anymore. So we'll do a couple of things and we'll test as we go. So at this point, now that we have built in this validity check, it's good to go ahead and test this part to see if this is working before we build anything else in the program. So I'm going to run this a couple of times with good values and bad values. You see there my menu's displaying. That's really good. Let's choose 3. 3 is a valid selection. That looks good. Now I'm going to try to run it. And this time I'm going to choose 0. And 0 is an invalid selection. And I can also see that this program exited with code 5. That's the number I was returning when the selection was invalid. And I could go through and I could test the boundaries and different numbers and so forth and so on. But I think for our purposes here, we've shown that those 2 checks are working. So now I want to evaluate what the user selected. And here is where it's easy to make a mistake. It's very easy to say right here, if selection equals 1, you chose Oreos. It's very easy to write that. It's a very easy mistake to make. But right here, I'm not testing to see if the selection was 1. I'm actually assigning 1 to the selection. And so if I run the program now, no matter what I choose, it's going to tell me that I chose Oreos. So if I choose Oreos, that's great, I chose Oreos. But if I didn't choose Oreos, let's say I choose Coke, it also thinks I chose Oreos. Because I'm not testing to see if selection is 1. I'm actually assigning 1 to the variable selection, and this will always be true. So I will always make this option. So I'm going to go build another couple of things, and then I'll go back and fix that. So we'll go ahead and say else if selection equal to and while I'm here, I'll set the price for each of these items as well. So I'll say that the price is equal to, say, $1.35 for the chips. Let's charge $1.50 for Oreos. And then, if I wanted to test for more than one item, I could write it like this. Selection equals 3, or selection equals 4. Now I'm going to hit this scenario where I'm choosing either a 3 or a 4. So maybe I don't really care which one it was. So I could say something like, you chose a drink. And set that price to $1.75. Now with Visual Studio, with this version of Visual Studio, I am seeing where I wrote selection equals 1 is underlined in green. And whenever you see that something's been underlined in a particular color, it's good to pay attention to what it might be trying to tell you. So I'm going to look right here. I'm going to hover over this section here, and it's going to give me a little warning. And it's saying that it thinks I made a mistake here, and I should have used equal equal. Now, it's not so confident that it's going to prevent it from compiling or anything like that, but it's just pointing out to me, maybe you need to pay attention to this, but this is probably not what you want to do. So that's a really nice feature there. I don't think I've seen that in older versions of Visual Studio, and you certainly can't count on your IDE or compiler to point out those problems for you. I also had a warning when I ran this program, and the warning also pointed out that assignment, that it says assignment of constant in Boolean context. Consider using equal equal instead. If you don't know what a Boolean context is, it's basically a scenario where we're trying to determine if something's true or false. That's the Boolean. And so I'm getting a warning as well about the same thing. But this is not a warning you can count on your compiler showing you. But it's nice when it does. So I'm going to go ahead and take a moment here to run it a couple times before I fix the problem. And so now I have my menu here. I want to choose a drink. So I'm going to choose Coke. And what I want to see is that I'm hitting you chose a drink. But when instead I'm up here at line 30 where selection equals 1, I'm assigning 1 to selection, and now it's going to be Oreos whether or not I want Oreos. And so now, even though we have built out this branching with a couple of different if sections in here, we will never hit any of this code or execute any of this because this first one will always be true. We left out the double equal. So let's fix the double equal now and rerun the program. I'm going to choose Coke again, and now the program is aware that I chose a drink. Now, I didn't write the program to tell me whether it was a Coke or a Sprite, but I can see that I am coming down to line 39 because the selection was either a 3 or a 4. So that seems to be working. Let's also test with chips while we're at it. Make sure that we're getting to that chips code. Okay. And it looks like chips is working as well. Now, a couple other things here. Make a comment about parentheses. I have to put what I'm evaluating for the if statement in parentheses. But inside of this, I have two conditions that I'm testing, and I've joined them with the or symbol. I can add parentheses around each one. Because of the order of evaluation, order of operations, I don't have to do that. But sometimes it is nice to add the extra parentheses just for clarity. But in this case, when you look at operator precedence, or is one of the lowest items in the precedence list. So if you don't add the parentheses here, your program will still work. All right. So what we've done now is we have validated what the user entered. We determined what they chose, set a price. The last thing I'm going to do is display that price. So I'll say amount due and price and inline. So let's try this out. Let's buy Oreos this time. It shows Oreos. My amount due is $1.50. So that looks good. Though I don't like how it wrote it. It wrote it as 1.5. So That's not quite what I want. And if I want to make sure these prices are displayed with 2 decimal places, what I can do is come back up here to my libraries, add the IO_manip library. And now we're going to, before we display this price, say cout fixed set precision 2. Now when I purchase the Oreos, it's not going to say 1.5, it'll actually say $1.50, so that looks better when we're working with money. Now there's one other thing I want to point out here. The word price, or the variable price, is underlined. So let's take a look at that. And it thinks I'm using uninitialized memory. So the reason I'm seeing this message is it thinks there could be some scenarios where price doesn't get set. Now I know from my data that I'm either going to do one of these 3 if statements, or 3 branches rather from these if statements, and I will always hit one of these 3 branches. I know that, but the program doesn't know that. And how I could have also written it was, I could have just said else, and I didn't have to check to see if the selection was 3 or 4, because at this point there weren't any other options. So if I had just said else, then the compiler would know that it would definitely be set to $1.75. This is a warning, and so with warnings, they're not always a problem, but you do want to pay attention to them. If I don't want to see that warning, another thing I can do is at the top of the program, go ahead and initialize price to 0, and then I won't ever see that message because price will always have a value. So I'll just go ahead and do that here, and that will get rid of that warning. And here I'm putting a space around the equal sign, but that's not required. I think Visual Studio likes to do that by default, but that is not a requirement of the language. So now I'm going to rebuild this program, and I'm going to see that well, now I have an error. Where do I have an error? I think it's just confused. Line 7. I'll try it. All right. I'm going to clean the solution. Sometimes some weird stuff gets out there, and rebuild the solution. Now it succeeded. Now I don't have any errors or any warnings. I'm not really sure why that had been flagged, but probably from some leftover edit that it just didn't clear out. All right, so this is our vending machine program. We displayed a menu. We validated the selection from the menu. We looked at the selections and set a price by using the == operator. As we move on, we're going to begin learning to use switch statements. And with switch statements, we can write this in a lot simpler way. So that's going to be easier to do, and we'll be doing that soon.